Hello, I'm Dale Gint, and this is a demonstration of the Utilities for Astro-Physics Mounts plugin for Nino 1.11. Nino 1.11 introduces what's called the Advanced Sequencer, and with it a plugin system. The plugin system can allow plugin authors to extend the functionality of the Advanced Sequencer through the addition of new sequence instructions, conditions, and triggers. The Utilities for Astro-Physics Mounts plugin implements a instruction called Create APPM Model, which will allow you to create an APPM model inside of the Nina sequencer itself. This functionality relies upon the upcoming release of APCC Pro 1.9. APCC Pro 1.9 has a number of new features, but two of them are important for the use of this plugin. One of them is the ability to use Nina as a camera device, basically. So you would have your camera connected in Nina as you normally would, and APPM will ask Nina for exposures through that camera. It would then solve those exposures and use that as a part of its model creation. The other thing that is good to have in APPM 1.9 is the ability to use the plate solver called ASTAP or ASTAP. If you're a Nina user, you're likely already using ASTAP as your solver, and so APPM would be able to use the same solver. And these two combined together will allow you to seamlessly make and quickly make a pointing and tracking model out inside of Nina sequencer. The plugin itself has one prerequisite inside Nina, and that is that the enable server setting be turned on. So if we go to options and the general tab, we need to make sure that the server enabled option is flipped to on. This is how APPM will be able to talk to Nina to get the exposures it needs. To install the plugin, we would go to the new plugins tab here and the available sub-tab, and Utilities for Astro-Physics Mounts will be listed here. All the plugins are listed alphabetically. And you can read over the description, see a screenshot. There's some links in here to the source repository. This is an open source plugin, as well as the install files and whatnot, as well as a home page up here. To install the plugin, you would hit the install button here in the upper right hand corner. I already have it installed, so it's grayed out, but you would have a button there to install it. And after a quick restart of Nina, you'll be able to find the plugin in the installed area of the plugin manager. And this will show you the options that are available to it. The options, of which there are 3 right now, are very basic, and the defaults are probably good for anyone. But you can specify, if you so wish, a specific settings file for APPM, a map file, or an alternate APPM location if it's not the default installation path. Now, as far as APPM itself and its settings, there are a few things you need to have it set up in order for it to use Nina properly in this context. So if we go to Astrophysics Command Center Pro and the Pointing Model tab, we can open up APPM through there by clicking this button. What we'll be able to find is it runs with its default settings, and so Nina here is set to be the camera, and the after complete action is set to no action. If you are using this plugin instruction for creating a model at the beginning of your evening or something like that, and then you want to go on an image of target immediately afterwards, you'll probably want to have this set to no action, because setting it to other other options here doesn't really make sense. You don't want to park the telescope and then only to unpark it and then go to another to your target. Once the model's done being created, APPM will load it into APCC Pro and quit. And with no action, your scope will be basically left pointing at the last point, modeling point there was in your model. And then you would go on after that to image your target. So with that, I suggest setting that to no action. And so once you close that, those settings will be saved as a default. And so when APPM is run next, it will be able to it'll use Nina as the camera, and it will do nothing once it completes the modeling run. Now, the instruction itself is very simple to use. We go to the sequencer area here. Now I already have something loaded, but the instruction itself will be over in the list of instructions under the Astrophysics Utilities section, and you can just drag it in. You can just drag it into the body of the sequence. It has one runtime option, and that is called Keep APPM Open. It defaults to off. Well, what this means is if you set that to on, once APPM completes its modeling run, it will stay open. It won't automatically quit out. And the reason why you'd want to use this is to review your modeling session after it's completed, or if you're debugging something. But if you want to run this in an unattended mode, then you'd want to keep that to the default of off. And what will happen is when this instruction is reached is that it'll start APPM. You'll see a window that pops up for 5 seconds that offers you a quick time to review the model and APPM settings that'll be used, and then it'll proceed with creating the model per your settings and map points. When it's done, the model will be put into place as active in APCC Pro, and APPM will quit. But when you're doing this model run, you'll probably want to do some other things around it. And I have a template called Do APPM Model, which does just that. And so I already have it here in my sequence body, so I'll expand it. What we see here is a list of instructions. So I wait for astronomical dusk because I might start this sequence, before dusk. And so I first want the sequence to stop here at astronomical dusk and not proceed until that time passes. And when it does pass, I'll unpark the telescope, and then we'll hit this parallel instruction set here, which contains 2 instructions that'll be executed in parallel. I'll salute to an alt-az of 89 degrees and 90 degrees azimuth, and make sure that my filter is set to luminance because I want to plate solve through my luminance filter. Now, the reason why I saluted the alt-az here of basically straight up with the scope on the west side is that you can do something like run an autofocus before you do the modeling. And what better place to do an autofocus run than straight up? But for the interest, in the interest of time for this demonstration, and the fact that my telescope is already in focus, I'm going to omit this instruction for now. So, but it's something you might want to do in case you know that starting out the gate that your telescope might not be in focus, or in focus enough for plate solving to work. So moving on, and then once these 2 instructions are complete, obviously the slew is probably going to take faster than the switch to a filter. The modeling session will run. Now after that, you might have your regular sequences like imaging a narrowband target. So I can go down here, drop in my narrowed band target template. Oops. And then let's just say I want to image the Elephant's Trunk Nebula, so I drop that in here. So what will happen here is that we'll wait for astronomical dusk, we'll do all this stuff, we'll create the model, and then when the model's done created, it'll fall through and we'll start imaging the Elephant's Trunk Nebula per my sequence instructions for this template. But we're not going to do that. I just wanted to show you that what a flow might look like for an evening. Without further ado, we'll start creating a model. Everything looks good. I have a 3D view of my telescope right here. And what we'll do is we'll press play. And we're going through my start of sequence instructions at the moment. We've gone through the time wait, we've unparked the telescope, we switched the filter, and now we're in the process of slewing to the Alt-Az that I specified here. Scope is on the west side of the pier, pointing almost straight up. And if I had an autofocus session, that would be running next. But instead we'll go to the model creation, which now starts. APPM is automatically started by the instruction. We see the preview window here, and the modeling begins. I have it set to do an initial plate solve near zenith. That's what it's doing right now. These are, I believe, 2-second long exposures. Bin 3. The camera in question is a QHY600, so it's quite large, and so 3x3 binning is going to make for some nice bright stars. And we're off to the races. If you've never done a modeling session through APPM before, you might have some questions about what all this stuff here in the point map means. The point map shows the points that you have configured for your model. I have 73 points, and you can see them all arrayed here. I also use horizon limits and meridian limits in APCC Pro. So what that means is that APPM can read those, and it's showing the horizon limit here, which is my visible sky is the light blue section, and my horizon, which is obscured by trees and other houses and stuff like that, is the dark blue area. So obviously we don't want to make points where we can't see the sky. So the model restricts points to the visible sky in this case. This magenta colored T in the middle here are my meridian limits. And so I have a certain degree of freedom with the counterweight up, and you can see here in the 3D model that my counterweights are up. And what this does is it just makes solving go faster, because you don't have to do meridian flips to get from one side of the sky to the other. And so we're now going through the typical model creation process here. I'll move this out of the way. You can see the full list. It's a little bit of a cloudy night out tonight, so we have 2 failed points right now. That's okay. This is just a demo. But as you can see, it's going through the process, imaging, solving, and entering in the solved coordinates into the table for that point, and then slewing to the next point and doing that again and again and again. A-Step is a fast solver, then coupled with a CMOS camera driven by a native driver, the download speeds are very fast. So getting through a 73-point model is going to take about, on my Mach 1, about 30 minutes, which is pretty good. Which is a pretty good clip. That means you can possibly, even depending on your skies, start this model around, civil twilight, perhaps, if you can see the stars at civil twilight, and have your model completed by the time Astro Dark comes around. So that's a quick overview of the utilities for Astro-Physics Mounts plugin. Again, it does require APCC Pro 1.9, and that's expected to be released in the summer of 2021. Thank you, and if you have any questions about this, you can find me on the APGTO mailing list. You can also find me on the plugins discussions channel on Discord. So if you have any suggestions or questions about how to use this plugin or some features for it, then please feel free to drop a message in either of those places and let me know. Thank you, and clear skies.